Hello everyone, welcome to the network security animation series. So in this particular session we will see how the Diffie-Hellman algorithm is used to exchange the symmetric key. So here we have Bob and Alice and Bob. They want to exchange a secret key, a symmetric key, through a medium. Now this medium is an unreliable medium, and the attacker Eve also has the access to the medium. So let us see how it works. So the very first step is either Alice or Bob, they generate two very large prime numbers. So in this case we have P and Q. Now this number P and Q, it can either be generated by Bob or by Alice, and both the numbers are prime numbers. And let us assume Bob generates the number and sends it to Alice through an unreliable media. Now because it is unreliable media, so Eve also gets this number P and Q. The next step is Alice and Bob, they generate a random number, a private number, that is X and Y. Okay, so Bob generates the number X, which is private to Bob, and Alice generates the number Y, which is private to Alice. And next is they do the calculation. Bob calculates R1 and Alice calculates R2. Now this is how the calculation is performed. So Bob finds R1 using this three variables such that it is Q raised to X mod B, and Alice does the calculation R2, which is equal to Q raised to Y mod P. Okay. And after calculating R1 by Bob and R2 by Alice, they share this number with each other through the unreliable media. So R1 is given to Alice and R2 is given to Bob. But since Eve also has the access to this media, so Eve also gets this R1 and R2. So this is what we see, that what is Bob has, and this is what Alice has. Okay, and that is what the Eve has. Now we just collect them together. Now the last calculation is finding the key with these variables. So what does Bob do? Bob uses the variables and calculates K1. Now this K1 is, as we can see, it is R2, which Bob received from Alice. So R2 raised to X. Now this X is only private to Bob and mod P. So this is K1, and Alice calculates K2 using this R1, which she gets from Bob, raised to Y, which is private to Alice, and mod P. Now this K1 and K2, they are calculated separately by Bob and Alice respectively, and mathematically if we do the calculation, what we see that this K1 is actually equal to K2. So both are same. We will see this example after this animation. So both K1 and K2 are same. Although Eve has access to P, Q, R1, R2, but she cannot generate this key by any means. So although Eve has R1, P, Q, R2, but she won't get the access to this key. So this Bob, in this particular algorithm, we saw that how this key is generated, how this key is actually calculated, we can say. So this K1 is equal to K2. So this is how this particular algorithm works. Now let us see one particular numerical example based on this. Now let us see one example. This is of Diffie-Hellman key exchange algorithm. So here we have Alice and Bob. They want to exchange a symmetric key. So the very first step is they select two variables P and Q, which are of course prime numbers. So P is 23 and Q is 7, and they either Alice generates this number or Bob generates, and they exchange this number through the unreliable media. Then Alice selects her private number X equal to 3, and Bob selects his private number as Y equal to 6. Then the next step is Alice calculates R1 by using this formula Q raised to X mod P, and this is what we get is R1 is equal to 7 raised to 3 mod 21, not mod 23 is, we get the answer as 21. So R1 is 21, which is calculated by Alice. And then Bob calculates R2 by using this formula Q raised to Y mod P. Now Q is 7, Y private number of Bob is 6, and mod P, that is mod 23, it gets 4. So this is R1 is 21. This R1 which was calculated by Alice is sent to Bob, and Bob, who calculated R2 equal to 4, he sends this number to Alice. Okay. Then the next step, the final step, is finding the key. So K1, Alice just does this calculation. K1 is r2 raised to x mod p, and K1 equal to r2 raised to x mod p, and she gets this 4 raised to 3 mod 23, she gets 18. Okay, and Bob does the calculation K2 equal to r1 raised to y mod p. Okay, and this calculation 21 raised to 6 mod 23 is 18. So what we see is that Bob and Alice both get the same number, that is 18, and this becomes their key, that is a symmetric key. Now any attacker, okay, who knows the value PQ, R1 and R2, because these 4 numbers they are shared through the unreliable media, but this X and Y they are not shared. So any attacker, for example if Eve is the attacker, she won't be able to calculate this K1 K2 because she has no knowledge about X and Y, and this X and Y they are never transmitted through that particular media. So this is how Diffie-Hellman key exchange algorithm works. So thanks for watching.